Okay, ma'am. Thank you, ma'am.
See here, today's topic is biodesulfurization of coal. అంటే ఏంటి అంటే the removal of sulfur from fuels like coal. The removal of sulfur from fuels like coal is known as desulfurization. Then why I have used biodesulfurization? Removal of sulfur from fuels like coal using microorganisms is called as biodesulfurization of coal. Then what is the necessity of removal of coal? నిజంగానే కోల్లో సల్ఫర్ కూడా ఉంటుందా? అవునా కదా? So for this, see here, the biological desulfurization of coal was first time studied using two types of bacteria. First, before going to that, generally the quality of coal greatly depends on the presence of sulfur compounds. అంటే ఏంటి? Coal quality is measured by means of presence of sulfur. What is that? If the sulfur concentration is high, the quality of coal is low. That means the quality of coal greatly depends on the presence of sulfur compounds. High sulfur coal is not suitable for industrial use. If the presence of sulfur in coal is high, then it is not suitable for usage in the industries because it starts releasing sulfur dioxide, which is a dangerous chemical which causes air pollution. So the quality of coal greatly depends on the presence of sulfur compounds, and high sulfur coal is not suitable for most industries because of environmental pollution, as it releases sulfur dioxide because of the combustion of the coal. Combustion అంటే burning of the coal. ఎందుకు వాళ్ళు కోల్ తీసుకొని దాన్ని ఏమి ఇట్లా మూటగట్టి దాచుకోరు కదా. కోల్ని తీసుకొని కోల్ని బర్న్ చేసి ఫ్యూయల్ తోని ఆ మంట దాని ద్వారా ఎనర్జీతోని దే విల్ బి ప్రొడ్యూసింగ్ సమ్ ప్రోడక్ట్ ఇన్ ది ఇండస్ట్రీస్. వెన్ దే burn coal, immediately sulfur dioxide is released because of the presence of high amount of sulfur in the coal. So the quality of coal is dependent on the presence of the amount of sulfur. Now see here, the biological desulfurization అంటే the removal of sulfur from the coal, from the removal of sulfur from coal using microorganisms was studied by, see here, pure cultures of mesophilic and thermophilic bacteria. Mesophilic and thermophilic bacteria help in biodesulfurization of coal. And mesophilic means which can grow up to 30 degrees centigrade or 32 degrees centigrade. అంటే ఇప్పుడు మనం ఉంటున్న టెంపరేచర్. Thermophilic means above 50 to 60 degrees centigrade they can grow, and such type of microorganisms, bacteria, are used for your desulfurization of coal. Next one, these organisms show their activity from coal when, see here, when coal is having 2 to 6% coal. అంటే ఏంటి? These organisms show their activity from 2 to 6% of coal. అంటే ఏంటి? ఇప్పుడు కోల్ గనక 92%, 98%, 94% సల్ఫర్ ఉంది, అట్లాంటి కోల్ ఏదైతే ఉందో ఈ కోల్ని కూడా ఇది డీసల్ఫరైజ్ చేసి ఆ కోల్ని ప్యూరిఫై చేస్తాయి అన్నమాట. నెక్స్ట్ వన్, ది మిసోఫిలిక్ బ్యాక్టీరియా ఆర్ థయోబాసిల్లస్ peridoxins or thiobacillus thioxidans. These are the two types of bacteria, mesophilic bacteria. Coming to the your thermophilic bacteria, that is sulfolobus బ్రెయిర్లెయి, ఇదేదో గుర్తుంటే ఉంచుకోండి, లేదా సల్ఫోలోబస్ బ్యాక్టీరియా అని గుర్తుపెట్టుకోండి. నౌ దీస్ బ్యాక్టీరియా వాట్ దే విల్ డూ ఇస్, వెన్ యు ఆర్ బర్నింగ్ కోల్, ఈ బర్నింగ్ ఆఫ్ కోల్ని నేను ఏమని రాస్తున్నా, combustion of coal anna burning of coal, it emits sulfur dioxide which causes air pollution. If sulfur dioxide mixes with water in the environment, it produces acid rains, that is water pollution. Okay, they cause water pollution. That means both air and water pollution, that is the sulfur dioxide causes environmental pollution. Next, the sulfur which is present in coal is in two forms, inorganic and organic. Okay, both it is present in two forms, organic and inorganic forms. This inorganic form is seen in form of zinc sulfide, FeS2. Next is PBS, that is lead sulfide. Next, calcium sulfate. These are the different forms of inorganic sulfur that are present in the coal. Next, this FeS is also known as pyrite. This FeS is known as pyrite, and calcium sulfate is known as gypsum. This is known as gypsum. And of all these, the removal of pyrite is generally done in the coal, because coal consists of sulfur in the form of FeS2, that is pyrite form, pyrite form, iron sulfide form. Now coming to the organic sulfur. This organic sulfur in coal is covalently bound into large complex-like structure. And suppose this is your coal. To this coal, it is joined covalently organic compound, and you cannot separate it, and you cannot say that this is coal and this is organic substance. Ante organic sulfur coal ki chala deggerga covalent ga atukkupoyi undi, you cannot separate it, and it forms a complex structure, large complex structure. And so the removal of inorganic sulfur from coal is easy when compared to organic sulfur. Why? Because this organic sulfur is very tightly bound to the coal, and it forms a large complex structure. Now coming to the mechanism of removal of inorganic sulfur. Okay. Now first mechanism is removal of inorganic sulfur. In this, what you have to do is, what is this generally used one? FeS2, that is pyrite. In parent FeS2 and gurtu lekapothe pyrite and raste chalu. Pyrite is the sulfur containing inorganic sulfur containing coal, and this on this what you have to do is take coal, mix it with water. Okay, take coal, mix it with water, it becomes coal suspension. It becomes a coal suspension. అంటే నీళ్ళల్లో కలుస్తుంది. కోల్ని మొత్తం నీళ్ళల్లో వేయండి, అదేమో బొగ్గు పొడి ఏమి నీళ్ళల్లో కలిసిపోయి పంచదార కాఫీలోను టీలోను కలిసినట్టు పాలల్లో కలిసినట్టు కలవదు. ఓన్లీ కోల్ ప్లస్ వాటర్ మిక్స్ అయ్యి ఉంటాయి అంతే. This is known as coal suspension. And over this coal suspension, what you have to do is, you have to use a jet of air along with carbon dioxide. A jet of air along with carbon dioxide is passed over this coal suspension consisting of FeS2. అంటే ఏంటి? కోల్ ఏముంది? కోల్ సస్పెన్షన్ consists of coal plus water plus your FeS2. On this, over this, you have to release a jet of your air along with carbon dioxide should be released. And now what happens is, in this suspension, coal suspension along with this, it consists of both mesophilic and thermophilic bacteria. As it has water and coal, it consists of, this suspension consists of mesophilic and thermophilic bacteria, and over this you will be releasing a jet of air plus carbon dioxide will be released. Then what happens? These organisms enhance the dissolution of minerals. అంటే ఏం చేస్తాయి? ఈ సల్ఫర్ ని they will separate. These organisms separate sulfur compound from coal. What it will do? It will mix the sulfur with oxygen or water, and it will be converting it into different compound, and so that the sulfur gets dissolved, and it separates from the coal compound. అర్థమైందమ్మా? కోల్ తీసుకొని దానిలో వాటర్ కలిపితే కోల్లో ఆల్రెడీ మనకు తెలుసు FeS2 పైరేట్ ఉంది. ఈ కోల్ సస్పెన్షన్ ప్లస్ FeS2లో ఒక జెట్ ఆఫ్ ఎయిర్ ప్లస్ కార్బన్ డైఆక్సైడ్ కనుక రిలీజ్ చేస్తే మనము ఇమీడియట్ గా ఏమైతుంది అంటే దీనిలో మిసోఫిలిక్ అండ్ థర్మోఫిలిక్ బ్యాక్టీరియా ఉండి అవి ఏం చేస్తాయంటే ఈ మినరల్ సాల్ట్ అయిన సల్ఫర్ ని సెపరేట్ డిజాల్వ్ చేసేస్తాయి. వాటర్ లో కానీ ఆక్సిజన్ లో కానీ మిక్సప్ చేసేస్తాయి, లేదా వాటర్ లో డిజాల్వ్ చేసేసి దాన్ని కోల్ నుంచి సెపరేట్ చేస్తాయి. there are two methods of biological desulfurization of inorganic sulfur from coal. There are two methods. A is indirect method and B is direct method. అంటే ఏంటి? ఇదంతా చేయడానికి two methods ఉన్నాయి. You can follow any one method. First let us see A, that is an indirect method. Indirect method means in this what you will be doing is this FeS2 which is present in an oxidized form. This is known as a ferric sulfide. Okay, this is known as ferric sulfide. It is an oxidized form. This is also known as pyrite. అవునా కదా? కోల్ లోపల ఇది ఉంది. దీనికి ఏం చేస్తామంటే ఫస్ట్ ఇట్ షుడ్ బి రెడ్యూస్డ్. ఆక్సిడైజ్డ్ ఫామ్ నుంచి రెడ్యూస్డ్ ఫామ్ లోకి దీన్ని మనము కెమికల్ కాంపౌండ్స్ ద్వారా అదే అయ్యేటట్టు జెట్ ఆఫ్ ఎయిర్ అండ్ విత్ ది యూజ్ ఆఫ్ ఎయిర్ ప్లస్ కార్బన్ డైఆక్సైడ్, దిస్ FeS2 is converted to your plus water. It is converted to a reduced form called ferrous sulfate. Ferrous sulfide. Okay, ferric sulfate నుంచి ferrous sulfide అయ్యింది. When it has converted into ferrous sulfide form, reduced form, now what you have to do is here the mesophilic and thermophilic bacteria will come into action. Now on the reduced ferrous sulfide only, on the reduced form of pyrite only, these bacteria can act. They cannot act on the oxidized form of sulfur. Now what they will do is they will oxidize this. Sulfur can be separated. Sulfur is separated because they dissolve this sulfur in the oxygen, and after that this ferrous is again converted into ferric form. It is again converted into a ferric form, and this regenerate primary oxidants under aerobic conditions. And in the presence of oxygen, first is in anaerobic conditions it is converted into ferrous sulfide. Now the mesophilic and thermophilic bacteria in the presence of oxygen, that is an aerobic organisms, they will convert this sulfur, they separate this sulfur and convert this ferrous sulfide again to ferric form. This is known as indirect method of removal of sulfur from this one. అంటే ఏంటి? కోల్ లోపల ఐరన్ ఉంటుంది, ఐరన్ లేకుండా కోల్ ఉంటుంది. ఇక్కడ ఏమైతుందంటే రియాక్షన్ చూడండి, FeS2 ప్లస్ 8H2O ప్లస్ కార్బన్ డైఆక్సైడ్ గివ్స్ రైస్ టు 15 Fe. ఇది మీరు ది బ్యాలెన్స్డ్ రియాక్షన్ మీరు చేసుకోండి అమ్మా. 2 plus 2SO4 minus 2 plus 16H plus. The carbon dioxide will be eliminated. Next is coming to the next one, 14 Fe plus 2 plus 3.5 oxygen plus 14H plus will give rise to, see here, 11 Fe plus 2 plus 7H2O. That means iron, sulfur is eliminated in the first step, and in the second step only iron is left over, and this iron is combined with your coal, and now the desulfurization has taken place using this indirect method. In the first step, in the second step, and the first step lo carbon dioxide and water maatrame participate chestunnayi, bacteria participate cheyatle. Second danlo matram bacteria participate chestayi. Enduku ante idi ferrous form, ferric form లో అది పనిచేయదు, ferrous form లోనే పనిచేస్తుంది. Next is coming to the B, that is your direct method. Direct biodesulfurization of inorganic sulfur from coal is, here what happens is, this is your coal. To this coal, there will be an intimate or a direct contact or the intimate physical contact between the bacteria and the sulfide mineral under aerobic conditions. అంటే ఏమైంది, under aerobic conditions బ్యాక్టీరియా ఏం చేస్తుందంటే, it will join, దీనిలో ఏమేమి ఉన్నాయి, FeS2 ఉంది, it will join to this. Suppose this is your coal, here sulfur is there, FeS2 is there. Now to this FeS2 the bacteria will come and join. That is, in the presence of oxygen, the bacteria will come and join to the sulfur, that is mineral present in the coal, and they will remove that sulfur tightly. They will bind to them and they will separate from the coal, taking back sulfur along with them or absorbing that entire sulfur into their cells. ఏం చేస్తాయి, బ్యాక్టీరియా వెళ్ళి సల్ఫర్ ఎక్కడుందో ఆ సల్ఫర్ మీద వెళ్ళి జాయిన్ అయ్యి ఆ సల్ఫర్ కాంపౌండ్ ని అబ్జార్బ్ చేసేసుకొని దాని బాడీలోకి తీసేసుకొని కోల్ నుంచి సల్ఫర్ ని సెపరేట్ చేస్తాయి. నౌ ది రియాక్షన్ ఈజ్, see here, FeS2 plus H2O plus 3.5 O2 అంటే డైరెక్ట్ రియాక్షన్. చూడండి దానిలో ఏమవుతుంది, Fe+2 plus 2SO4 minus 2 plus 2H+. చూడండి ఇక్కడ రియాక్షన్ పెడితే ఇక్కడ చూడండి, ఇక్కడ ఫస్ట్ రియాక్షన్ ఏమో సల్ఫర్ వెళ్ళిపోయింది, సెకండ్ దానిలో ఏమో ఐరన్ మళ్ళీ ఫెర్రిక్ కాంపౌండ్ తయారైంది. ఇక్కడ ఏమైంది, అంతా ఒకే రియాక్షన్ లో జరిగిపోయింది. దిస్ ఈస్ నోన్ యాజ్ డైరెక్ట్ biodesulfurization of inorganic ones. Next, this, see here, this is taking place. In these direct methods, many microorganisms are used for biodesulfurization using direct method. In this, you see the presence of mesoacidophilic bacteria. The example for this, ACIDIO, acidothioBacillus peridoxens. Peridoxens అని ఎందుకు వచ్చిన పేరు, because it is acting on iron, that is ferric form is converted to ferrous form, and again this ferrous form is converted to ferric form in the presence of this peridoxens. Because of this peridoxin, it is known as ferrous, is known as iron. And next, in the acidic, that is at a pH of 2, the pH should be highly acidic. At this pH, the bacteria will participate in this reaction and convert it into, the sulfur will be separated and ferrous form is converted again into ferric form and the coal becomes desulfurized. Next one is another bacterium called as your thermobacillus. The thermobacillus bacteria is, here is a sulfolobus acidocaldarius. This will remove 96% of inorganic sulfur and 50% of total sulfur. It will separate this thermobacillus bacteria. So this sulfolobus bacterium, it will sulfolobus acidocaldarius, it can separate 96% of inorganic sulfur from the coal, that is pyrite form, and along with that it can separate 50% of total sulfur from the coal. Next, there is another bacterium called as leptospirillum. ఇగో చూడండి ఇవి బ్యాసిల్లస్ అంటున్నా, బ్యాసిల్లస్ అంటే వీటి షేప్ ఏంటి, ఈ షేప్ లో ఉన్నాయి రెండు బ్యాక్టీరియాలు. కానీ లెప్టోస్పైరల్లమ్ స్పీషీస్, it will be spiral in shape. These leptospirillum species, they can convert this, they can remove 85% of pyrite, that is FeS2, and from coal in 40 days. That means when you leave this leptospirillum bacteria on coal, within 40 days, it will remove 85% of Fe sulfur from the coal. Next, at a pH of 1.5, the pH should be very, very highly acidic, that is 1.5 in a fermenter. Next is coming to the biodesulfurization. of organic sulfur. The removal of this organic sulfur is very difficult when compared to the inorganic sulfur, because this organic sulfur, it will tightly bind with the mineral compound, that is sulfur, present in the coal, so that its removal will be difficult, and it will absorb that sulfur into its body and convert it into different forms. Now, this bacterial enzymes produced during pre-adaptation, then what happens? Suppose this is your coal, here is sulfur, to this sulfur bacteria is joined. Immediately what this will do means, this bacteria will release certain enzymes. When they join to this sulfur, bacterial enzymes produced during the pre-joining of adaptation or produced during the pre-adaptation of cells on various organosulfur compounds increased desulfurization from 38 to 80%. This is sulfur, this is bacterium. This bacterium will come and tightly bind to this sulfur compound. So this bacteria will release enzymes. And when it releases enzymes, this remove the sulfur from 38 to 80% of desulfurization takes place because of these bacterial enzymes. అంటే బ్యాక్టీరియా వచ్చి జాయిన్ అయినా ఒక ఇండైరెక్ట్ మెథడ్ లాగా మైక్రో ఆర్గానిజమ్స్ ఎంజైమ్స్ రిలీజ్ చేస్తే ఆ ఎంజైమ్స్ వెళ్ళి సల్ఫర్ ని రిమూవ్ చేసేస్తాయి. దిస్ విల్ బి డన్ from 38% to 80% of desulfurization takes place with the help of the bacterial enzymes. The best enzymes are rhodococcus. బ్యాక్టీరియల్ ఎంజైమ్స్ అక్కడ చెప్పాను, ఇనార్గానిక్, థయోబాసిల్లస్, సల్ఫోలోబస్ అని, తర్వాత లెప్టోస్పైరిల్లం. ఇక్కడైతే థైరోడోస్పైరిల్లం, తర్వాత బాసిల్లస్ సబ్టిలిస్. ఇది రోడోస్ కోకస్ అన్నాను కాబట్టి రౌండ్, ఇది బాసిల్లస్ సబ్టిలిస్ అంటే రాడ్ షేప్డ్. అండ్ నెక్స్ట్ ఈజ్ మైకోబాక్టీరియం. Mycobacterium tuberculae అంటే tuberculosis causing organism. This is also bacillus in shape. When these are exposed to coal, immediately the organic sulfur present in the coal gets biodesulfurized. అంటే ఏంటి, ఈ మూడిట్లలో ఏ బ్యాక్టీరియా అన్నా కనుక కోల్ కి దగ్గరకు వచ్చింది అంటే కనుక ఇమీడియట్ గా ఒక కోల్ గనక ఈ బ్యాక్టీరియాకి ఎక్స్పోజ్ అయితే, లేకపోతే బ్యాక్టీరియానే కోల్కి ఎక్స్పోజ్ అయితే, లేదా కోల్ బ్యాక్టీరియాకి ఎక్స్పోజ్ అయితే, ఇమీడియట్ గా ఈ మూడిట్లలో ఏ బ్యాక్టీరియా అయినా సరే బయోడీసల్ఫరైజేషన్ చేసి ఆర్గానిక్ సల్ఫర్ ని కోల్ నుంచి సెపరేట్ చేస్తుంది. ది బెస్ట్ వన్ ఈజ్ rhodococcus. It is extensively used to degrade organosulfur compounds from coal. Now coming to the mechanism of biodesulfurization of organic sulfur from coal. Okay. Next, ఇప్పటిదాకా మనం ఇండైరెక్ట్ మెథడ్ చూసాం, ఇప్పుడు ఆర్గానిక్. ది మోస్ట్ కామన్ కాంపౌండ్ యూజ్డ్ యాజ్ ఎ మోడల్ ఫర్ ఆర్గానిక్ సల్ఫర్ ఇన్ కోల్ ఈజ్, see here, dibenzothiophene. See here, dibenzothiophene is the most important organic sulfur present in coal. Okay, this dibenzothiophene is the organic form of sulfur present in the coal. Now this should be converted. What is this? This should be converted by a bacterium called as rhodococcus or rhodococcus. Rhodococcus అంటే ఏంటి, ఇది జీనస్, ఇది స్పీషీస్. rhodococcus is the microorganism that will convert this organic sulfur, separate this organic sulfur compound. This separates the organic sulfur compound from coal. What it will do is it will convert it into cis 1,2 dihydrothio or benzothiophene. See here, It will be converted first into cis-1,2 dihydrobenzothiophene. And now it is again converted into cis-4,2,3 hydroxythiophene. It is converted into cis-4,2,3 hydroxythiophene butanoic acid. Next it will be again converted into trans 4,2,3 hydroxythiophene butanol or butanoic acid. Now again it is converted, see here, again it is converted into 3-hydroxy 2-formyl benzothiophene. And this pathway is known as 4S pathway. This is known as 4S pathway, that is in 4 steps. This one, 1, 2, 3, 4 is the first step, second step, third step, and fourth step. In these 4 steps, that is 1, 2, 3, and 4. Within these 4 steps, this sulfur compound is separated. So it is known as 4S pathway. It is known as 4S pathway. This pathway is known as 4S pathway, and rhodochorus bacterium is used in this process to remove the organic sulfur from this coal. That is dibenzenothiophene is nothing but it is a model organic sulfur in coal, present in coal, and this is converted into your last form, that is 3-hydroxy 2-formyl benzothiophene. In this form do not have organic sulfur. It is free from sulfur, free from organic sulfur. This compound is free from organic sulfur. So this 4th compound is produced because of the action of rhodochorus organism. In this, the dibenzothiophene, an organic sulfur compound present in coal, is first converted by this bacterium into cis-1,2 dihydrobenzothiophene. Later it is converted to cis-4,2,3 dihydrothiophene butanoic acid. And third one is, it is again converted into trans 4,2,3 hydroxythiophene butanoic acid. Later on, finally, it is converted into 3-hydroxy 2-formyl benzothiophene. And this compound is free from organic sulfur, and it is present in the coal. When it is present in the coal, this coal is free from organic sulfur, and it can be very easily used in the industries. This is about your desulfurization of your coal. See here, desulfurization of the coal. If coal has this sulfur compound, the coal is suitable for most of the industries, as it releases, because of the combustion or burning of coal, it releases sulfur dioxide into the environment that causes environmental pollution. To remove that, not to allow it, we have to remove this sulfur compound from the coal. But surprisingly, our Indian coal has very least or less amount of sulfur in it. So it is worldwide accepted coal. Without any biodesulfurization, we can directly use our Indian coal. When you go for Spanish coal or when you go for American coal, these coals or European coal, they are filled with large amount of inorganic and organic sulfur. For that reason, the Indian coal is the best coal. So everybody are looking at our Indian coal, and we are exporting our Indian coal to other countries, because without any biodesulfurization process, we can directly use our Indian coal in the industries. That's all for today. We'll stop here. And in the next class, that is at 12 o'clock, again, I will start a class. And at 12 o'clock, we'll see the next topic. So in the next class, we'll look into the next topic, that is your Next topic is your bio-delignification using enzymes or bio-delignification by enzymes. That is also very simple topic. ఇప్పుడు ఇందులో ఏమీ కష్టం లేదమ్మా, కొంచెం చదువుకోండి. ఈ లాస్ట్ ప్రాసెస్ ఉంది కదా, ఇది గుర్తులేదు వదిలేయండి, ఏమీ పర్వాలేదు, ఇక్కడ వరకు రాయండి. ఈ ఆర్గానిజమ్స్ యూజ్ అవుతాయి ఇన్ఆర్గానిక్, ఎందుకంటే ఇది చాలా కష్టం కాబట్టి సెపరేట్ చేయడము. ఈ ఆర్గానిజమ్స్ యూజ్ చేస్తాయి, ఎక్కువ రోడోకోకస్ ఆర్గానిజమే ఎక్కువగా యూస్ఫుల్ అవుతుంది, ఎక్స్టెన్సివ్లీ యూజ్డ్ ఫర్ బయోడీసల్ఫరైజేషన్ ఆఫ్ ఆర్గానిక్ సల్ఫర్ ఇన్ కోల్. అంతవరకు రాసొదిలేండి. ఇది గుర్తుంటే ఈ టెక్నిక్ రాయండి, మెథడ్ లేకపోతే లేదు. పైనదంతా రాస్తే చాలు, దట్ బికమ్స్ యువర్ లాంగ్ క్వశ్చన్, లాంగ్ ఆన్సర్. Is it okay? With this we will be completing our next topic, that is biodesulfurization of coal. Okay students, I'll stop here and in the next class we'll meet again. Thank you students.